We have looked at how to solve lots of different types of equations, and now we are ready to move into solving inequalities. Inequalities, instead of an equal sign, they're going to have a less than sign, greater than sign, less than or equal to, or greater than or equal to sign. This is something you learned in the 7th grade. You did multi-step, like basically two-step is what I should say, inequalities, and now we're going to move into multi-step inequalities. Now, here's what's nice about this. This is the same process as multi-step equations, but there's one difference. There's one thing you have to look out for that if you don't notice it, you'll miss some steps of some problems. Here's the one exception. When you multiply or divide both sides of an inequality by a negative number, you're going to have to reverse the inequality. Okay, so let's look at a couple of examples to refresh your memory about how this looks. So we're just going to look at a couple of one steps here. I have negative 2x is less than 6. This is negative 2 times x, so I'm going to divide both sides by negative 2. By what kind of 2? Negative 2. What am I dividing by? Negative 2. I say that to emphasize we are dividing both sides by a negative number, so we have to reverse the inequality. So where we had a less than here, we get the answer x is greater than negative 3. So our original inequality symbol was a less than sign. Since we divided both sides by a negative number, we reverse that to a greater than symbol. Okay, let's quickly review how to graph an inequality. Remember, this has lots of numbers that make this true. There are lots of things we can plug in for x that make negative 2 times x less than 6. So according to our solution, that's everything greater than negative 3. So since it's just the greater than symbol, we put an open circle on negative 3, and everything greater than negative 3 goes to the right. Okay, so for example, if we plugged in negative 2, negative 1, if we plugged in 0, if we plugged in 5, anything greater than negative 3, it would make this a true statement. If we plugged in negative 2.5, it would make it true. If we plugged in negative 2.9, for example, everything we have shaded is a solution to this inequality. Now let's look at another one-step inequality. This is x divided by negative 4 is greater than or equal to negative 1. So we're going to multiply both sides by what? By negative 4. By what kind of 4? Negative 4. And since we're multiplying both sides by a negative 4, our answer becomes x is less than or equal to negative 1 times negative 4 is positive 4. So we started with a greater than or equal to symbol. We multiplied both sides by a negative 4, and our answer is x is less than or equal to 4. So to review how to graph this, if your symbol is a less than or equal to, you put a closed circle on that 4, and this is less than, so the arrow, notice it is an arrow, it needs to have an arrow at the end, goes to the left. So in this case, 4 is included in our solution. If we were to plug in 4 here, we would get a true statement, whereas over here, if we were to plug in negative 3, it's not part of the solution, we would not get a true statement. Okay, so that's the one rule you need to be aware of. Now, this would be a great lesson if you want to try these out and see if you can handle them on your own. Always turn the video back on, check your work, see if you did it correctly, or you can do it with me. Okay, so this first one, I have 4 times the quantity x minus 3 is greater than negative 24. I'm going to do that distributive property first. I get 4x minus 12 is greater than negative 24. This is just a two-step inequality. I'm going to add 12 to both sides, and I get 4x is greater than negative 12. Then I'm going to divide both sides by a positive 4, so I get x is greater than negative 3. Now when I want to graph this, notice I gave you a blank number line down here. I'm just going to put a scale on here as long as your scale is consistent, as long as I can tell what you're counting by. It doesn't matter which numbers you use, which part of the number line you choose to use. So this is greater than negative 3, so I'm going to put an open circle at negative 3, and greater than is to the right. So everything that this red arrow, or array is the official math term for it. If I were to keep going to the right, everything greater than -3 would make this original inequality true. Okay? The next one, x minus 3 times the quantity x plus 2 is greater than 4. Just like the steps of multi-step equations, I'm going to do the distributive property, and I get x minus 3x minus 6 is greater than 4. Then I'm going to combine like terms. I have x minus 3x, so I put 1x minus 3x, I combine those, and I get -2x minus 6 is greater than 4. At this point, I'm to a two-step inequality. I'm going to add 6 to both sides, and I get -2x is greater than 10. Then I'm going to divide both sides by -2. By what kind of 2? -2. So since I started with a greater than symbol, I'm going to reverse that, and I get x is less than -5. I'm going to pick a scale for my number line. This is just what I chose. You can choose a different part of the number line and still be correct. I'm going to put an open circle on -5, and since it's less than, I'm going to go to the left.